All right, today we're going to be doing an integration by partial fractions example. We have the integral of 8 over 3x cubed plus 7x squared plus 4x dx right here. We're going to start by factoring the denominator here. See, we can take out an x, and the inside would become 3x squared plus 7x plus 4. Now, what two numbers multiply to be 12 and add to be 7? That'd be 4 and 3. So that can be written as 3x plus 4 times 3x plus 3. And this can be simplified to x plus 1. So finally we have x times 3x plus 4 times x plus 1. So our fraction here becomes x times 3x plus 4 times x plus 1. Now we want to find a way to make this fraction equal to the addition of three fractions that we're breaking up with three unknown constants. And the denominators here are going to be each of our factors. So we have x for the first, we have 3x plus 4 for the second, and x plus 1 for the last. And our goal here is to find these values for a, b, and c. In order to do this, we want to multiply everything here by this denominator. So this left side will cancel out. From this, we get 8 on the left, since all this cancels out. We get a over x times all this, so these x's will cancel out, and we're left with an a times 3x plus 4 times x plus 1. Now this 3x plus 4 will cancel here for the b, so we're left with b times x plus 1. Finally, the x plus 1's cancel out here, so we're left with c times x times 3x plus 4. To find our values of a, b, and c here, we want to find what values of x will make these parentheses go to 0, and as a result make these entire terms go to 0. To start, I'll choose x equals 0 because that's in these two. So when x equals 0, our left side is still 8 since we have no x's over there. This becomes a times 3 times 0 plus 4, which is just 4, and then 0 plus 1, which is just 1. Next, that becomes 0, so all of this becomes 0, and this becomes 0, so all of this will become 0. So we're just left now with 4a equals 8, which is the same as a equals 2. Next, we're going to choose a value of negative 1. From this, we still have an 8 on the left side. That will go to 0, this will go to 0, and then we're left with a c times a negative 1. Sorry, this is a negative 1. We're left with a equals c times a negative 1 times, this would be 3 times negative 1 plus 4, which is 1. So we have negative c equals 8, or c equals negative 8. Finally, we need to figure out what value of x will make this 3x plus 4 go to 0. We could just check that real quick. So x needs to be negative 4 over 3. So when x is negative 4 over 3, what do we get? Well, like we know, this will go to 0, and that will go to 0. So in the middle here, well, first we have an 8 equals b times negative 4 over 3 times negative 4 over 3 plus 1, which is negative 1 over 3. This right here over here becomes a positive 4 over 9 times b. Now if we just multiply both sides by 9 over 4, we're left with 8 times 9 over 4 equals b. We can cancel this 4 out and make this 8 become a 2, and we see that b equals 18. And now we have our three values that we can plug in into our a, b, and c right here, which equals our original function. So then we can integrate this instead, which becomes much easier. So now we have the integral of a over x, so 2 over x, integral of 2 over x. And we have b over 3x plus 4, so plus the integral of 18 over 3x plus 4. Finally, for c, we have minus 8, so minus the integral of 8 over x plus 1. Now this right here just becomes 2 times the natural log of the absolute value of x. Now here, this would be, we see 18 natural log of 3x plus 4, but since there's a 3 attached to this x, we need to make sure to use chain rule and multiply this whole thing now by 1/3, because it's kind of the opposite of when you're taking a derivative. When it's an integral, you're trying to cancel it out. So I'm just going to put a 3 under that 18. So we're left with plus 18 over 3 times the natural log of 3x plus 4. And finally, this last one is easy. We get minus 8 times the natural log of x plus 1. Remember, this is all because the integral of 1 over x equals the natural log of the absolute value of x. Don't forget to add a plus c at the end here, since we have no bounds. And that should be our final answer.